Hello Algebra 2 students, hope your day is going well today. I have about 18 quizzes in already before the deadline. Thanks for getting those in and finding the location better. Today's lesson 8.4 is about properties of logarithms. And so one of the key things to remember is that logarithms are exponents. So to know the properties of logarithms, you have to know the properties of exponents. So just a quick review here. We've got three main ones that we're going to be revisiting today. The product property, which says if I have a product of two powers, same base, then I can simply add up the exponents. Then there's the quotient property, similar to the product, only now we have division instead. And so much like it's the opposite with the product adding, then we're going to do the subtracting of the exponents. Jump the line, change the sign. And then the last one is the power of powers. So the power property, for short, would be if I have a power raised to a power, then that's when I actually multiply the exponents. And I left off the simpler ones. X to the 0 equals 1, x to the negative n equals 1 over x to the n. Jump the line, change the sign. And then the ones that had two bases. So for example, xy to the n, that equals x to the n, y to the n. And same for a fraction. So if I raise a fraction to a power, I can do the numerator to that power and the denominator to that power. But these first three, those are the ones that we're going to focus on today. All right, so that being said, here are the logarithmic properties that go with those exponential properties. So this is the new stuff for today, relating to these exponent properties. And so the first one here, and we're just going to use base b, and then I've got an m and an n multiplied together. So that's the same thing as splitting this apart, saying that log base b of m plus log base b of n, that's the same thing as this log base b of mn. And that's our product property. I'm just going to abbreviate it prop. Then our second one, I guess I should have up here too, m, n, b all have to be positive, and b can't be 1. So there are a couple of restrictions. So all of these numbers and variables are representing positive values, no negatives, no zeros. And then also b can't be 1. All right, and then our second one here, this is now when we have a fraction, logarithm of a fraction, that's the same thing as the logarithm of the numerator, subtracting the logarithm of the denominator. And that's our quotient property of logarithms. And then the last one here, maybe the most useful when we start working with equations, is the power property. So if I have m raised to the x power, I can rewrite that as x log base b of m. Notice the x, the exponent, now is down on the regular level with the other numbers. That's particularly helpful when we're solving equations. That comes in the next lesson. And so this we'll just call the properties. All right, so let's start using some of these ideas here. The first example has us go through a bunch and just say, okay, here's a statement. Which property or properties, plural, allows us to say this? So here's the first example. So this will be part A of this one. So let's do log base 5 of 2 plus log base 5 of 6. And then if you understand this property, when we have addition here, that could be rewritten as log base 5 of 12. Putting them together with multiplication, not addition. Remember, these are exponents. So when these are added, we're actually saying we're multiplying regularly. So this would be the product property for its reason. All right, here's another one. So what says we can say log base 3 of 16 subtract log base 3 of 2 equals log base 3 of 8. So if you think of this property now, subtraction means division, so I'm going to do 16 divided by 2. That gives me the 8. That confirms this is the quotient property. Third example, you might guess now, I've got log base 2 of x to the third, and now I'm saying that's the same thing as 3 times log base 2 of x. And that's our power property. Do a couple more of these. So this next one will have log base b of x squared divided by y. And that's going to be the same as 2 log base b of x minus log base b of y. And so now this one actually does two things. It drops this 2 down out of the exponent of that x squared term, and so that's going to be our power property. And this division, this fraction here, is turned into subtracting, so that's the quotient. So this is a combo of 2, both the power and quotient property. And the order that you write those is random. Either way is fine. All right, I think I can fit one last one on here. 3 log of x plus 5 log of y equals log of x to the third, y to the fifth. And this one now, this would be 2 properties. Notice we've got that power 3. It was down in front of this log, now it's in the exponent of the x, and so that's the power property. And this addition turning into multiplication, that's the product property. So that's the first section of problems. You just see what's happening, which property allows that. All right, 2 more examples with multiple versions, and then we're done. Let's see here. This lined up better. There we go. All right, so that was justifying. Now we're going to go to simplifying. This is our second example. Here's the first one. So what would log base 4 of 64 subtract log base 4 of 16 give me? Now I do want to mention on that last problem that we did, there wasn't a base there. That's a common log. I didn't bother writing the base 10, but if you put that in there, that's fine. But when there's no number for the subscript on the log, it's the common log base 10. I didn't mention that in the last problem, sorry. All right, so this one now, subtraction, that could be log base 4 of 64 divided by 16, and then simplifying that, 64 divided by 16 is 4, so it's log base 4 of 4, and that would be fine for the answer. However, log base 4 of 4 or log base of anything when it's that same thing, that actually can be simplified to 1. So in this problem I would accept either log base 4 of 4, that's fine, or if you realize, oh yeah, that can actually be equal to 1, then that's fine. Either one of those would be good. Alright, we'll do a couple more of these. So 6 log base 5 of x plus log base 5 of y. What would that simplify to? I'll just give you a little pause here if you want to try it yourself. And now the answer would be log base 5 still, x to the 6th y. So I do the 6 as the exponent on x, and then the plus sign makes it multiply. So that's how I got the product of x to the 6th and y. Alright, last one of these. It's not just limited to 2 things. This one's going to have 3 actually. 3 log base 10 of 2, didn't bother, it's a common log, plus log of 4 minus log of 16. See if you can simplify that one. I'll give you a little pause here. Alright, so this could be rewritten then. Still common log. You could have base 10 there, not needed. This would be 2 to the 3rd for this first term, plus, that's going to be times of 4, minus, that's going to be divided by a 16. So it's the log of all of that. And then we would just simplify this. This gives me 8 times 4 is log of 32, all over, whoops, just over 16 gives me log of 2. Sorry, that went off the screen there a little bit. So final answer, log of 2. Now, just as a reminder, when we're doing calculations, because this is base 10, our calculator will have a button, the log button will evaluate that. And so what this log base 2, log base 10 of 2 is saying is that 10 to the x equals 2. In other words, this value of log 2 is the exponent for base 10 that gives me 2. So if you do that on your calculator, you hit that log button, that's the base 10 of 2, you get a number like 0.301029997. What that's saying is 10 to that 0.301029997, that equals 2. And if you type that into your calculator, you will see that that indeed is the case. Alright, last example does the opposite, is just going to have us expanding these logarithms. Whoops, a little too far. Alright, so this instruction would simply be expand each logarithm. Basically the opposite of what we were just doing. So can you simplify it if it's expanded? Can you expand it if it's simplified? That's really the goal of today's lesson. Alright, so here's our first example. We got log base 7 of t over u. And so expanding that out now, because it's a fraction, that's going to put a minus sign between my two log terms. Log base 7 of t, the numerator, minus log base 7 of u, the denominator. Done. That's all you have to do. Alright, part B. Log, not base 4, common log here, of 4p to the 3rd. Remember, you don't have to put that base 10, but if you do, that's fine. So this would be log of 4 plus, and then 3 log of p. So the plus sign takes care of the product here. The p to the third, that's this 3 log p. I didn't give you much time to pause that, sorry. All right, third example of this section. So how about log base 2 of 7b? I'll give you a little pause here, see if you can do that one. All right, this one will be still log base 2, but of 7 plus log base 2 of a b. 2 more. All right, how about this one? Log of the fraction y over 3 squared. Give you a little pause here, see if you can do that one. This one you should have had 2 log of y subtract 2 log of 3. This was a common log again, so if you had base 10s written in there, that's fine. Don't need to, though. All right, last one here. Log base 7 of a to the third b to the fourth. Go ahead and see if you can do that one. I'll give you a little pause here. All right, if you did this one correctly, you should have had 3 log base 7 of a, that gets me my a to the third term, plus, here's that product part, and then 4 log base 7 of b. All right, that's the lesson. The homework is on page 449. We're doing 2 through 42 even, but you can go ahead and skip number 32. All right, have a good day. Do everything your parents say.